Hi, this is revision for the first physics topic, which is all about motion. The first thing that everybody needs to know is the difference between a vector and a scalar quantity. So scalar quantities are measurements that we can take in physics that have got amounts, sizes. However, vector quantities have both sizes and directions. We can measure different things in physics such as temperature, distances and time. The specific direction doesn't matter, so therefore it's a scalar quantity, but you could have different amounts. So for example, you could have 5 meters or you could have 1,000 meters. Vector quantities have sizes and directions. So one thing that we'll measure lots of in physics are forces, and it's very important to know the direction of that force. Therefore it's a vector quantity. So you could have 5 newtons to the left, or you could have 25 newtons to the right. Therefore it has a size and a direction, so it's a vector quantity. Another good way to show the difference between a scalar quantity and a vector quantity is by using a map. So if we take a journey from the school entrance to Jarrow, then I can show the difference between distance and displacement. So if we walked down Field Terrace and then up Beedburn Road, if we've walked 300 metres down Field Terrace and 400 metres up Beedburn Road, our total distance will be 700 metres. So that's got an amount, 700. It doesn't have a direction because we've went to the left and then up on the map. So the specific direction doesn't matter. However, displacement, if you look at the definitions, is the distance between a start point and an end point in one line with a direction. So if that's 400 meters between them 2 points, it would have a specific direction. So the displacement between school and Jarrow would be 400 meters northwest. Another thing that we can use this map for is to show the difference between speed and velocity. So if we walk down Field Terrace at 1.5 meters per second, and then we'll walk up Beedburn Road at the same speed, 1.5 meters per second, our speed is 1.5 meters per second. It's constant speed. So that's a physics term just to show that it's always the same. Our velocity, however, has changed. So if this is part A on the map, our velocity was 1.5 meters per second west, and then when we change direction, our velocity has changed, and this is important later in the course. So now our velocity will be 1.5 meters per second north. So speed is a scalar quantity because it has amounts, whereas velocity is a vector quantity because it has amounts and also directions. Okay, so the next thing that everybody needs to know are distance time graphs. You know it's a distance time graph because it's got distance on the y-axis and time on the x-axis. This is a distance time graph for the story about the tortoise and the hare. If you don't know this, the tortoise plodded along and actually beat the hare. He did the race in less time, therefore he won. Whereas the hare is naturally faster, but he stopped at various points because he's lazy. You can use this to work out the speed. To do that, you need to know the first of the physics equations, the formulas that you need to know. So the first equation that you need to know is that speed equals distance divided by time. Speed in physics is measured in meters per second, not miles per hour, meters per second. Therefore, distance is measured in meters and time is measured in seconds. If we have a look at the green line for the tortoise, we know how far it has travelled and we know how long that took. So if you want to pause the video now and work out the average speed of the tortoise, that would be useful. Figure out if you can do this by yourself first. Okay, so the distance that the tortoise travelled, so it started at 0 meters and got 2,700 meters away from that. So the distance that the tortoise has travelled, very straightforward, 2,700 meters. How long did that take? So if we follow this line down, what you'll find is it took 15 minutes. 15 minutes. All of them 15 minutes contain 60 seconds each. So what we need to do to turn 15 minutes into seconds is 15 times 60. If you do that on your calculator, you should get 900 seconds. So speed equals distance over time. 2,700 meters divided by 900 seconds equals 3 meters per second. So the tortoise's average speed was 3 meters per second. The next thing that you may have to do in an exam or on a test is work out various speeds. So if we split the hare's journey up into 4 different sections, A, B, C and D, there's different speeds, and you can tell that because the gradient's different. Right, the first one, section A, has a flat line. It started at 0 meters and it ended at 0 meters. So it took 2.5 minutes for that to happen. The speed's 0 meters a second, because if you do 0 meters divided by 150 seconds, you're going to get 0. Part B on them is a little bit trickier. If you want to pause the video now and work out what was the hare's speed at part B, that would also be useful, so you can figure out, can you do this yourself? Right, one mistake that students often make is they'll go, okay, right, well that took 7.5 minutes. So the distance travelled was 1,800 meters, and that took 7.5 minutes. That's not actually true, because part B on the graph started at 2.5 minutes. So that journey actually took between 2.5 and 7.5 minutes. So the difference between them is 5 minutes. 5 minutes times 60 seconds will turn that into seconds. So 300 seconds. And if we do the distance travelled, 1,800 meters divided by 300. So we can see on part B, the hare's speed was 6 meters per second. What would be useful now is to stop and think, right, well that's when 6 meters per second on part B. The tortoise's average speed was 3 meters a second. So what you'll find on a graph is, so 3 meters a second will have a shallower gradient, and 6 meters per second will have a steeper gradient. So the faster something's going, the steeper the gradient on a distance time graph. Again, if you want to pause the video and figure out, well, how fast was it going on part D and part C, you can do that now. Part C was also going at 0 meters per second, and part D, just like part B, was also going at 6 meters per second. So what should the gradients have in common if on part B it was going 6 meters a second and then part D was also going at 6 meters a second? Well, the gradient should be exactly the same. And if you want to have a look on your screen now and use a ruler, you should see that these lines are actually parallel. The next thing that everybody needs to know is that acceleration is the rate of change in velocity. I'm going to explain what that means now. So there's an equation that goes with this, and that is that acceleration is a change in velocity, or a change in speed, divided by the time it takes. I think everybody knows if something's accelerating, it's speeding up. Nothing speeds up straight away. It takes time for that to happen. This equation can be turned into letters, so in physics we quite like using letters because it's quicker. It also helps to explain this equation a little bit further. So if something's accelerating, so say a car is going 0 meters per second and it speeds up to 30 meters per second, has its speed changed? Yes, it has. It's changed by 30 meters per second. Could a car also accelerate if it was already moving? So if a car's going at 10 meters a second and it speeds up to 30 meters a second, has its speed changed? Yes, so it is accelerating. So these letters, V is the final speed and U is the original or the starting speed. So we could use them letters. So the final speed take away the starting speed will give us our change in speed, and the time that took would also be needed to work out an acceleration. So if we use that equation, we can apply that to this question. So if you want to pause the video and figure out, can you already answer this question, that would be really useful. So do that now. Okay, so in physics, you get 3 marks for these sort of calculation questions. You get 1 mark for remembering the specific equation that you would need to know. So A equals V minus U divided by T. That's going to get you 1 mark. The second mark is for substituting in the correct values. So here we'll have the change in speed, and here we'll have the time. So V was the final speed, take away the starting speed, divided by the time that it took. So the third and final mark, so you get another mark for this, but the third and final mark is for solving that. So 20 divided by 4 equals 5 meters per second squared. It's now useful to have a look back and figure out, well, what is actually happening when acceleration is taking place. So the acceleration of this car was 5 meters per second squared. What does that mean? So the car took 4 seconds to change speed. How fast was it going at 0 seconds? Well, it was already going at 10 meters per second. What acceleration means, so 5 meters per second squared, this means that it's getting faster by 5 meters per second each second. So that's why it is squared. It's just a lot easier to write than 5 meters per second each second. That would take too long. So we'll just write 5 meters per second squared. So how fast was the car travelling at 1 second? Well, it's sped up by 5 meters a second. So the car at 1 second will be going 15 meters per second. At 2 seconds, it will then be going 20. At 3 seconds, it will be going 25. And then finally, at 4 seconds, we know that it was going at 30 meters per second because it told us in the question. So acceleration is a rate of change in velocity. So you do need to remember that equation, and you do also need to be able to apply it to different questions. The last thing that everybody needs to know are velocity time graphs, and you'll know it's a velocity time graph because it'll either have velocity or speed on that y-axis, not distance. So what's happening at the various parts in the graph? So at part A on the graph, it started out at 0 meters a second and it's went up to a speed of 15 meters per second. So here it's not traveling at a constant speed, it's actually accelerating. So we can use this equation to work out the speed at the various sections of the graph. If you would like to pause the video now and figure out, can you already do this, do that now. Okay, so part A on the graph has a change in speed of 15 meters per second. This takes 10 seconds. 15 divided by 10 is 1.5 meters per second squared. On part B on the graph, it is 0 meters per second squared. It isn't speeding up at all. Part C has a change in speed of 10 meters per second, and this takes 10 seconds. 10 divided by 10 is 1 meters per second squared. And finally, part D on the graph has a negative acceleration, negative 1.25 meters per second squared. The reason is because U, that is the final speed, and the final speed here is 0. It started out at 25 meters per second, so the starting speed, 0 take away 25, divided by the time it took, 20 seconds, is actually negative 1.25 meters per second squared. So a deceleration, if something is slowing down, it'll have a negative number if you calculate it on a velocity time graph or by using the equation A equals V minus U divided by T. The final thing that you could be asked to do with a velocity time graph is to calculate the distance that it has travelled at the various points. To do this, you would work out the area under that blue line. So first of all, we'll do part B. So on part B, it is going at a constant, a steady speed of 15 meters per second. And if something is travelling at 15 meters per second, and it does that for 2 seconds, it would travel 30 meters. Here it's actually travelling for 10 seconds. So each of them seconds it's doing 15 meters of distance. So during that time, it would do 150 meters. A simpler way to work this out is by using the area of shapes. And all we've got here are rectangles and triangles. So if a rectangle has a height of 15 meters per second and a base of 10 seconds, we can just simply times them together to give us that. If you would like to pause the video and work out the distance that it's travelled at A, C and D, you can do that now. Part A is a triangle. So if it was a rectangle, you would be doing 15 times 10, but it's not. We'll have to half that because it's just a triangle. And if you did that, you should have got 75 meters. On part C, what most students like doing is separating these into the two shapes. So here on top, we've got a triangle, and that has an area of 50 meters. Underneath that, the rectangle, just like B, has a distance of 150 meters. So together on part C, they have a combined distance of 200 meters. So under that line, if something was speeding up from 15 to 25 meters per second, and that took 10 seconds, it would travel 200 meters. The final part, part D, it would travel 250 meters. So if we're going to add them all together, 250, add 200, add 150, add 75. During that journey, this object would have travelled a total of 675 meters. Here are some typical speeds that you need to memorise. Thank you so much for watching the video. Well done. Now could you please try some questions. You don't really know if you understand something until you've tried a few questions. I'll put some links in the descriptions. Make sure if you're doing foundation, so if you're in set 4 and below, do the foundation ones. If you're doing the higher, click on the higher link. If you're doing triple science, click on the triple science link. I'm then going to put on videos on how to answer some of them trickier questions. So keep updated. Thank you very much. Well done for watching this. Good luck.